All right, well, hello everyone. Thank you for attending my presentation today. My name is Amy Bogolin, and I am here to present to you some work that I did while at the University of Texas, Rio Grande Valley, which was comparing novel and traditional sampling methodologies to analyze the population status of the Rio Grande cooter. The scientific name for that species is Pseudemys gorzugi. So first, for a brief overview, for those of you who are not familiar with this species, it is a freshwater aquatic turtle found throughout southwestern Texas, southeastern New Mexico, and northeastern Mexico, along the Rio Grande, Pecos, and Devil River systems. You can see in that lower picture there's a historical range map, with that red being its projected historical distribution, and the yellow being actual locality information. It's very colorful. It has an elongate oval carapace with black, yellow, and green concentric circles, and it only recently received species designation in Ernst 1990, breaking from its previous classification as a subspecies of Pseudemys consina. There are a lot of conservation concerns regarding this species. To date, there's been very little research conducted on it, and it is very elusive, so it can be hard to study. However, the research that has been conducted has documented few populations of gorzugi, and in particular lack of juveniles in Texas. So this has led to a lot of concerns about recruitment for this species. They do face numerous threats, such as habitat modification and destruction. These are very heavily utilized river systems. There's been several large dams erected, as that one shown in that picture above. Also, a lot of issues with pollution, which you can see in that lower photo. And there's been some concerns about collection to the pet trade. And they do have a very small range, so they are very susceptible to these habitat changes. As a result, they maintain several current listings. They're considered near threatened by the IUCN, threatened in Mexico and in New Mexico, and they're a species of greatest conservation need in Texas. Additionally, they're undergoing a species status assessment by the U.S. Fish and Wildlife Service to determine if they should be federally listed, with a decision to be made by the end of the fiscal year of 2021. So the goals of the study were to compare the effectiveness of novel and traditional sampling methodologies while locating and quantifying gorzugi populations. In order to do this, we conducted drone, visual, and trapping surveys at 44 unique localities throughout southwestern Texas. Additionally, we developed and implemented an environmental DNA protocol at these and additional sites to determine the current gorzugi distribution, and we characterized gorzugi habitat using multispectral imagery. However, for the time constraints of this presentation today, I'm only going to be presenting on that first objective. For our drone surveys, we used a DJI Matrice 600 Pro unmanned aerial vehicle. We attached a gimbal to stabilize the camera during flight, and flights were conducted with the Maps Made Easy app and the DJI GS Pro app. These flights occurred at 30 meters above ground level with an 82% overlap and a 2.2 meter per second maximum speed over about a 1.25 hectare area. For a digital camera, we used a Sony ILCE Alpha 6000. We attached a prime lens to increase the zoom and a polarizer to cut back on glare from the water. This digital camera was manually focused to 29 meters, the ISO set at 320, the f-stop at 6.3, and the shutter speed at 1/1000. Additionally, we attached a GeoSnap Express to our drone and our camera, and this triggered our camera to take photos on a 1-second interval, and it geotagged our photographs, which were useful for analysis. For this analysis procedure, all the pictures were individually sorted through, and any photo containing a turtle was pulled aside, and the turtles present were identified and quantified. And then the GPS stamps associated with all these photos were uploaded onto Google Maps to ensure that we weren't double counting any turtles. Since we did have a very high level percent overlap with those transects, we wanted to make sure that we weren't making any erroneous counts. So we have some photos illustrating that procedure there to the right. A and B show our sympatric turtle species. In A on the left, you have the Trachemys scripta elegans and Pseudemys gorzugi on the right. And in B, there's Apollon spinifera on the left, and then the Pseudemys gorzugi on the right. And then that lower photo shows you a snip from one of our test sites of that Google Map image. So each yellow dot represents an individual photo, and each circle represents an individual turtle. So in this particular instance, anywhere between 1 to 4 photos represented one unique turtle. And those are color-coded, with white being the spinifera, that yellow-orange is the gorzugi, and that red is the scripta. For our traditional sampling methodologies, we used visual and trapping surveys. Our visual surveys were conducted with Eagle Optics Ranger binoculars. These were 15 minutes long, and we varied the order between these and our drone surveys to make sure that neither of these surveys were having a negative impact on turtle behavior. We wanted to make sure that we weren't reducing the potential counts in that following survey. All of the turtles were quantified and identified, and the observer made sure they were at least 3 meters from the shoreline at all times to reduce the impact they were having on these turtles. For our trapping surveys, we deployed 3 hoop net traps per site. These were set 1 to 5 meters from shore and baited with canned sardines. Traps were checked after 24 hours and set for 48 hours total, with trapped turtles identified, quantified, and processed. In order to compare the effectiveness of our sampling methodologies, we examined the average number of turtles detected, identified, and identification percentages for these methods. First, we had to determine our ideal sampling effort, as these different methods had different sampling units. So we constituted equal sampling events, being a 15-minute drone survey, a 15-minute visual survey, and the 48-hour trapping period, all occurring over that same 1¼ hectare area. Any effort deviations, more than 2 standard deviations from the mean, were excluded, and we additionally excluded sites and site visits with no turtle detections. We averaged abundance and identification percentages per site to avoid pseudo-replication in our data set, and as our data was non-normally distributed, we used Kruskal-Wallis and Wilcoxon multiple comparison tests for analyses. For our drone surveys, we conducted 73 surveys at 42 unique localities. This resulted in 84,441 photographs that were analyzed and led to the detection of 640 turtles, including 307 gorzugi, 93 scripta, 89 spinifera, and 151 that were not identifiable. Gorzugi were found at 18 sites via this method. Our identification percentage was 82.3%, and our site with the highest number of gorzugi detections had 56 gorzugi. There's our range map illustrating our results from our drone surveys. So the way that this is color-coded is those purple circles represent sites where gorzugi were detected, and orange is localities where they were not detected via this particular method. For a drone, we were very pleased to see it had minimal disturbance to wildlife in general, in particular with our turtles. On a few occasions, we would have turtles slip into the water. That was aerial basking, but for the most part, the drone would pass overhead and the turtles had no noticeable changes in their behavior. We did have a very unique aerial viewpoint with the drone surveys as well. There was numerous occasions where we were able to document turtles in this drone imagery that we were unable to see from shore. And this led to a very high number of overall detections. For one survey event, our drone survey detected 80 turtles, where our visual only detected 10 and our trapping only detected 6 turtles. In another survey event, our drone detected 66 turtles, where our visual only detected 18 and our trap only detected 1, all in the same survey area. We did have a high identification percentage, so we were able to identify the majority of the turtles that we were documenting in this drone imagery to species. And we had numerous occasions of behavioral documentation as well, such as mass basking, which is illustrated in photo A, subaerial basking seen in photo B, courting behaviors in photo C, and some foraging depicted in photo D. For a visual survey, we conducted 84 surveys at 44 unique localities. This led to the detection of 315 turtles, including 91 gorzugi, 28 scripta, 25 spinifera, and 171 that were not identifiable. Gorzugi were found at 15 sites via this method. Our identification percentage was 50.8%, and our site with the highest number of gorzugi detections had 7.7. We did have a pretty low identification percentage with this method, much lower than what's seen in a lot of prior visual surveys on different species. This could be due to the lack of animals that we had out aerial basking. Most of the turtles that we saw were swimming in the water. They're often obscured in aquatic vegetation or obscured by glare coming off that water from the sun. So it was particularly difficult to differentiate between gorzugi and scripta on a lot of our occasions. And this here is our visual map. And once again, that's set the same way with those purple circles representing areas where gorzugi were detected via our visual surveys. For our trapping surveys, we conducted 66 surveys at 39 unique localities. This led to 9,275 trap hours and the detection of 219 turtles, including 67 gorzugi, 99 scripta, 53 spinifera. Gorzugi were detected at 18 sites via this method. Our identification percentage was 100%, and our highest number of gorzugi detections was 7 for a site. Our trapping resulted in pretty mixed success for gorzugi. We did have some occasions where we were very successful. We also had many times that we were really struggling to trap any at all, particularly at some very high density sites. This could be due to issues with bait type. Adults are primarily herbivorous. We use canned sardines, which has been used in previous literature very successfully with the New Mexico populations, but more of a mixed success amongst those Texas populations. So they could respond more positively to a different type of bait. Additionally, we noticed a seasonal trend. The majority of our trapping occurred in these hot summer months, where in the spring and the fall, we had a little bit of higher numbers. So if we had extended our sampling season, either of those directions, we may have seen a little bit more success with that as well. And here is our trapping map, once again set up the same, with that purple representing localities where gorzugi were detected. So for a methodology comparison, there was no significant difference found in turtle detections or gorzugi detections, but there was a significant difference found in turtle identifications. So that top chart illustrates that there. Our drone was able to identify more turtles than our visual surveys, but there was no difference seen between drone and trapping surveys. And that lower graph shows the significant difference in identification percentages. Our trapping had a higher identification percentage than both our drone and our visual surveys. And once again, our drone outperformed our visual surveys. For our total detections, while we did fail to result in a significant difference, our drone did have higher mean values. This could be due to those non-parametric analyses we used, which obscure the difference in these values. When you look at the raw data, the maximum amount of turtles detected for each survey, our drone survey that detected the most turtles detected 80 turtles in total, where visual detected 28 and our trapping detected 18. Additionally, our methods performed pretty similarly in low density sites. When there weren't a lot of turtles to be documented, there just wasn't one method clearly outperforming the others. However, for identifications, our drone proved to be superior to the visual, and our drone was the same as trapping in mean identifications, which in this instance is actually an argument for drone surveys, as trapping is always going to result in perfect identification. But essentially, the drone proved that it could conduct these species-specific surveys, which really is essential for wildlife management. You're not going to be as interested in how many turtles are in a particular area, but how many of each particular species, especially when you are looking for these species of conservation concern. So for our conclusions, our drone was minimally invasive and it had a unique aerial viewpoint, which led it to the opportunity to detect a lot of these turtles that these other methods may have been looking over. However, there are numerous requirements with this particular method between different licensing and permits that are specifically required for the drone. And it is a newer technology, so there are some technological issues that are still being worked out. However, there has been great progress made in this particular area, even just from the start of our study. And it has continued to become more feasible to implement this new technology as it becomes more popular and just more widespread. For our visual surveys, they were low effort, low cost, and quick and easy, which is why it's often one of your first line steps that you're using when you're accessing an area. However, they are subject to observer bias. Your results are only going to be as good as that observer is at locating and identifying turtles. And in our instance, we did have a pretty low identification percentage. We weren't really able to get that species-specific information we're looking for. For trapping, one of the main benefits of trapping is you have a turtle in hand, so you're always going to be able to identify it. You have the opportunity to collect population health data, tissue samples, vouchers, certainly a lot of unique benefits with this particular method. However, it is labor intensive and it can become expensive because of that. It's subject to numerous sampling biases. There's all sorts of literature out there about how different turtle species respond to different types of bait age, whether or not there's a turtle already present in a trap. Some species just really don't trap well in general. And trapping is also unfortunately subject to trap theft. So depending upon what your particular needs are, what particular data you're trying to obtain, and what your resources are, is going to depend on what your method, I guess, would be most suitable for your use. However, we found that that drone did have a lot of unique advantages and certainly should be a top contender when you're looking for a way to survey for freshwater turtle species. But being able to combine all these different methods together, we were able to have our most thorough assessment of this area, and we created an updated range map for this particular species. You can see there to the right, just a few more purple circles than you had seen in any of our previous individual maps. But being able to combine all this data certainly was advantageous in being able to survey for this species. And with that, I'd like to acknowledge the University of Texas Rio Grande Valley for the opportunity to partake in this project, as well as the Texas Comptroller Office for providing funding, and several outside organizations and individuals who all helped assist in the project and permitted sampling on their different properties. And if I have any questions, I can answer those, and I can also always be reached for follow-up via that email address below.
Do you see your questions in the chat?
Yes, just pulling those up right now. All right, so question 1. How far below the water surface could these turtles be detected? Wondering if this could work for estuarine sea turtle surveys. So I don't have a particular measure on that. A lot of our surveys occurred in the Rio Grande, the Pecos River, and those, I don't have the exact depths of those, but there were several occurrences where we were able to actually document turtles that were all the way on the substrate of these river surfaces. It's certainly going to be dependent upon how turbid the water is. I mean, from one sampling event to the other, we have certainly had differences in the amount of turbidity. But if you did have clear water, you should certainly be able to see several meters below that water surface. A lot of sea turtle work has actually already been done with drone surveys. Sea turtles are much larger, at least most of them are, than a lot of these freshwater turtle species, so they do have that going for them too. But I know it has been used already to document a lot of sea turtle surveys and has been pretty successful with that. Question 2, you mentioned possible seasonal effects on trapping. Did you detect any seasonal difference in your other 2 methods? Yes, I'd say we had some of that as well, particularly noticeable, I guess, in both our drone and our visual surveys, is in those earliest sampling dates and in those latest sampling dates, we did have a few more turtles aerial basking, where in our bulk summer months, it was a very infrequent occurrence to actually have that happen. That picture I showed of that mass basking, there was 26 gorzugi on that rock. That was very early in the year. When we came back to that site a few times later on, the same time we didn't witness that same thing, which we figured was just due to the much higher temperatures that you're experiencing in South Texas during those summer months. Question 3, do they plan on using this method to study any other species anytime soon, more cryptic and secretive species like the soft shells and muds, etc.? I do not know of any plans to study more cryptic species with this method. Certainly, your more success is going to be for these large basking turtles, just because smaller you have, the more difficult it is going to be to detect them via this imagery. And if anything you have that's like burrowing in mud, you know, it's just not detectable on the surface as something flying overhead, you're not going to be able to see it. One thing that I have heard of, but I don't think it's actually been used to date, but for some of these more cryptic species would be potentially using thermal cameras and actually looking for those thermal heat signatures in areas where you might not be able to visually detect them. So that would potentially be an opportunity as well. But we did document our soft shells in our drone surveys, and several occasions they were often harder to see just to their habitat use, but it is certainly possible. In question 4, isn't it difficult to identify turtle species only with carapace and top of heads in the pictures? What are the key features used to identify each species? So yeah, certainly the more different in overall appearance your turtles are, the easier it is going to be to differentiate them. We were lucky in that we only had 3 sympatric species in these images, and the gorzugi had these very bright, unique yellow bands on the top of their head, which was one of our top things that we were looking for. The spiny soft shell obviously is very different in appearance also ever between the colorings, just that elongated snout, the red-eared slider, and many occasions we were able to actually see that red marking by their ear. Another thing with gorzugi is they have bright orange webbing between their, I guess between the, like on their feet. So we basically tried to use a combination of these. If there were any instances where we weren't 100% sure on what the identity was, we did classify it in that unidentifiable. But for the most part, like I said, we generally had identification percentages in the 80%. In question 5, were you questioned by Border Patrol officers while flying drones over the Rio Grande? Yes, we frequently saw Border Patrol. I would always call them beforehand to alert them of our presence, but that seemed to never actually make it out to the officers in the field. However, the Border Patrol was generally very happy to see us, just doing, you know, turtle research. Many of them actually showed us pictures they had of the species we were looking for at our site, and they were always very excited to see the drone fly. So we certainly didn't mind having them around. And I believe that is all my questions. So thank you all for attending, and I'm going to pass it off to the next presenter.